Hello you all, my dear. Jai Hind. Today's topic is spherical aberration. Right, my dear, I told you all in my last class also that today's topic is an important topic because whenever we are doing a mirror concepts, we are doing this concepts that what is spherical aberration, who caused, why it caused, and how to reduce this aberration, right? And there are some more important points which I'll tell you along with the topic. My dear, here I have written aberration. You can see the meaning of aberration is defects. It is a defect. You know that in class 10th you have myopia, hypermetropia. Similarly, this is also a kind of a defect which cause a blurred image. Any defect cause a blurred image, right? So this is also a defect. And I have name of this defects as a spherical aberration, means this is spherical defect. Matlab, this is due to the spherical nature or spherical portion. So this defects is caused due to the, or it is occurred due to the spherical portion. Now if I say it occur due to spherical portion, now my dear, if I say this word, it means it lies in spherical mirror. Because both the spherical mirror are spherical, having a spherical portion, right? And this kind of aberration is lie in the spherical portion because of that, and therefore it will be in spherical mirror also. This is quite natural. So in all spherical mirror, this kind of defects you will observe, and we should aware about it, how to reduce it, why it causing, and all media. Now the next part is that how it cause. I said this is lie in spherical portion of the things, and because of that it occur in spherical mirror also. But now how it cause, who cause it? This is due to it caused due to the large aperture of a spherical mirror. So my dear, try to understand. I said spherical aberration, that is a defect. Where did you observe these defects? You observe these defects in spherical portions, right? And this is occur due to the spherical portion, and therefore it lies in spherical mirrors. And who cause in spherical mirror also? It is not in all spherical mirror which has a small aperture. This is one kind of a reduction. This is why we say in assumption take a mirror of small aperture. Why? Because there should not be a spherical aberration. Please. So this is the reason why we say that small mirror should have a small aperture. So many derivation of all derivations of mirror formula, everywhere we take this assumption, take mirror of small aperture, because it is a spherical mirror. If it is a large aperture, it allow the defect, and that defect is spherical aberration, which is not good for the derivation or not good for anything. It is useless, because if there is a defect, what is the use of it? So now let us try to understand how the large aperture cause these defects. How the large aperture of the mirror causing these defects. So let us draw this diagram. Here I am drawing the mirror of large aperture. Say this is the mirror, and I have drawn concave mirror. Here is the pole. Right, this much is enough. This is the principal axis. You can see I am writing here principal axis. Now my dear, try to understand. I have drawn concave spherical mirror, right? Try to understand, since the mirror has a large aperture, I am writing here large aperture. So now, if the mirror has a large aperture, a wider beam of light, wider rays of light, wider wider rays of light will be fall on the mirror. Mirror का aperture बड़ा है तो wider beam of light will fall. Maximum beam of light will fall. Wider beam of light will fall on the mirror. Simple concept. So my dear, this is the number of rays falling on the mirror. You can see they are falling on the mirror. And I will call this as wider parallel beam of light. Wider parallel beam of light. Why I use word wider? Because aperture is large. Am I clear? Wider beam of light, maximum beam of light will gather on the aperture because of on the mirror, fall on the mirror. I hope it is clear. Simple concept. If mirror has a small aperture, sir, beam of light will be little less because the wider beam will be passed in the surrounding. There will be no mirror like this. See that? Now if the mirror has a small aperture, where is the question of this beam of light? They will go in surrounding. Refraction will take place when they will fall on the mirror. So why wider beam of light has got a chance, or why we have taken the concept of wider beam of light? Because the mirror has a large aperture, my dear. Because of the large aperture, wider beam of light will fall on the mirror. And what is wide beam of light? A group of rays of light. A group of rays of light, I talked all in my earlier video. The group of rays of light are called beam of light. And they are parallel. So it is wider. Now my dear, the ray of light which is far away, this is the principal axis. The ray of light which is far away from the principal axis are called marginal rays. Marginal rays. And the rays which are close to the principal axis are called paraxial rays. Right? So please take this part, and if it is new to your concept, please note this concept. The rays which are away, wider away or far away, wider away or far away from the principal axis are marginal ray, and the ray which are close to principal axis are paraxial rays. Say I have taken here as a paraxial rays. I have drawn 1, 2, 3 marginal rays. For me, I assume that they are away, and these two are paraxial which are close to principal axis. Similarly, here also they are paraxial rays, and here it is marginal ray. Okay. Now let us look at the concept. So wider beam of light will fall. Wider beam of light के वजह से, my dear, the rays which are away from principal axis, I will call that as a marginal, and the rays close to principal are called paraxials. Now, what will happen? The reflection will take place, and after reflection, look at where the marginal ray are converge. Say this is one marginal ray. From here also I have taken the marginal ray. Similarly, say this is another marginal ray. Here also say this is another marginal ray. Say this is third marginal ray. Here also I am drawing. Look at this marginal ray are converged to a point close to pole. Marginal rays are converged. I assume that these three are marginal rays, and here also these three are marginal rays. These two are paraxial. Even here these two are paraxial because they are close to principal axis. Now what is the point to note? After reflection or marginal refracted rays, क्या बोल सकते हैं इसको? Marginal refracted rays, they converge, they focused at a point close to pole. मैंने language बोला, they focused or converged at a point close to pole. Let I will name this as FM. That is focal point due to marginal refracted ray. Focal point due to marginal refracted rays. I observe here. And my dear, the property says that when paraxial refracted rays will be reflect they converge to the principal focus of the mirror. This is the focal point I observed due to paraxial rays, FP. And believe me, this is the principal focus of the mirror, of the given mirror, actual principal focus of the given mirror. So paraxial rays converge to actual principal focus of the mirror, whereas marginal rays converge to a point close to the pole but not the principal focus. Close to pole they converge and they create new focal point. Whereas paraxial rays, they converge to a principal focus. I hope you are getting me. So now here, my dear, what is very important point to understand, that why these defects occurred. These defects occurred because, my dear, there are two different focal points you can see. Am I clear? My dear, what is the meaning of this? I have a number of refracted rays here. But these refracted rays are not converged or not focused at one single point. They converge or they focus at 2 points. Paraxial rays focus at the principal focus, and the marginal rays are focused, the marginal refracted rays are focused at a point close to pole. And my dear, this is the defect. That means, sir, all refracted rays are not converging at one point. They are converging at two different points. And why this happened, my dear? Because of the large aperture. Very right. Assume karo ki aperture large nahi hota, so there is no question of this marginal rays. Only there will be a paraxial rays, because aperture is small. So marginal rays don't get a chance to fall on the mirror, right? Because mirror short hai. So only the paraxial rays will be there. This is a principal axis. So all will be converged to one point, and that is called principal focus. Like this. If the mirror has a small aperture, because of the large aperture, the marginal rays also get a chance. The rays which are away from the principal axis are also get a chance to fall on the mirror, and when they reflect close to the pole. They reflect and converge close to the pole instead of converging at the principal focus. So now the science said, oh God, how it can be possible? Because if the rays after reflection will not converge to one point, then this is the defect. The rays after reflection must converge to one point. Because if there are two different focal points, it means, my dear, you can assume there will be, the image will be blurred. There are one reflected is coinciding here, another is coinciding here. It gives the blurred image. So my dear, this is what is the concept of spherical aberration. So now I will ask you to draw this diagram, and see, this is also I have reduced it. I reduced it by taking the mirror of small aperture. You can see this is the defect diagram and this is the reduced diagram. This is the reduction diagram. This diagram shows that I am reducing the spherical aberration by taking the mirror of small aperture. So if you wish to draw the diagram, please draw the diagram. Otherwise I am wipe it out. I am giving you 2 minutes and then I will start writing about spherical aberration. So now, my dear, what is spherical aberration? Spherical aberration, here I am writing the definition. Point number 1, spherical aberration is a inability is an inability, you can say. Spherical aberration एक inability है, right? So is an inability of a spherical mirror, but not all the spherical mirror. I said it is caused due to large aperture. So of a spherical mirror of large aperture, so it is inability of the spherical mirror of large aperture, not all the spherical mirror. Because if the spherical mirror has a small aperture, I will not get a marginal ray, and there is no question of the focusing of or converging of refracted ray at close to pole. Only there will be a paraxial rays and they will converge or focus at one point after reflection. There is no two focal point, my dear. So that's what it is, not in a small aperture mirror. So spherical aberration is an inability of spherical mirror of large aperture. Don't forget this line, of large aperture, right? Is inability of spherical mirror of large aperture to focus or converged. किसको फोकस करना है या कन्वर्ज करना है? टू फोकस्ड और कन्वर्ज्ड रिफ्लेक्टेड रेज, टू फोकस्ड और कन्वर्ज्ड रिफ्लेक्टेड रेज at a single point, right? It is not converging here at one single point. This reflected ray are converging at point here close to pole, and this reflected ray converges to principal focus. So that's what I have written. Spherical aberration is an inability of a spherical mirror of large aperture to focus or converge reflected rays at one single point, you can say, at one point instead of at single point, you can say, at single point. And these reflected rays, my dear, you know which are. They are marginal reflected rays as well as paraxial reflected rays. They are not converging at single point. That is principal focus, you can say. You can see they are not converging at single point, that is principal focus. This is converging close to pole instead of principal focus. So my dear, take there, this is a beautiful answer. Spherical aberration is an inability of spherical mirror of large aperture to focus or converge. Focus को ही converge बोलते हैं. In case of concave mirror, we can write converge. Refracted ray, you can say all the refracted rays at single point, that is principal focus. Am I clear? So my dear, now if this is an inability, so what I supposed to do, and what else you have observed? Point number 2, the paraxial rays here the paraxial rays, or you can say reflected paraxial rays, here the reflected paraxial rays, this one, are converged or focused at principal focus, that is F. P I have written FP, right? Here the reflected paraxial rays, the paraxial rays which reflected paraxial rays are converged or focused at principal focus. Whereas, I am writing here, whereas marginal reflected rays are converged. Marginal reflected rays, you can see here, marginal reflected rays are converged or focused at a point. What is the name of point? FM I have given. At a point FM close to the pole, close to the pole of a mirror. So by writing the point number 2, point number 3, you confirm that sir, this mirror of large aperture are not converging or focusing all the refracted ray at single point. They are converging at two different points, you can see. So my dear, because of this point number 4, we can conclude the number of refracted rays, you can see number of refracted rays, that is marginal and paraxial, I am writing in bracket, formed number of refracted rays, that is marginal as well as paraxial, formed on the surface they form on the surface, you can see on the surface of the principal axis, you can see here also. So the number of refracted rays, that is marginal and paraxial, formed on the surface, right? They formed on the surface with different focal point. Or you can say with more than one focal point. This is a beautiful line. This number of refracted rays, that is marginal refracted rays and paraxial refracted rays, they form on the surface of the principal axis. They form here, no? They form the image, right? So they form on the surface, they converge to the principal axis, you can see. So they form on the surface with more than one focal point. Hence the image obtained is blurred. This is, my dear, the problem of spherical aberration, and therefore, my dear, this is the diagram to avoid spherical aberration, my dear. And how you come to know this is a diagram to avoid spherical aberrations? That pehla reduction formula is take a spherical mirror of small aperture. So if as soon as I take the mirror of small aperture, the rays will be paraxial because they are close to, only those rays will be fall, only a limited rays will be get fall on the mirror because aperture is small. So all those rays are called paraxial and they but natural focus at a principal focus. No other focus point I will observe. So that is one way of reducing the spherical aberration, that is by taking a mirror of small aperture. So in my another video, part 2 video of this, I will give you the reduction in brief and the uses of paraboloidal mirror. Paraboloidal, that is parabolic mirror. Please take care. This is related with your board examination 12th standard. Thank you and Jai Hind.